Good morning, everyone. This is Julie McDonald with Microcom Technologies, and I'd like to thank all of you for attending today's webinar with RF Elements. Today's host is Tassos Alexio. He'll be presenting today, and if anyone has any questions, feel free to submit them in the question box, and Tassos will answer them at the end of the presentation. Thank you again, and Tassos, I am finished for now. Please know that the floor is now yours.
Excellent, thank you. Thank you for having us, and thank you everybody for joining this morning's webinar. So today we'll be discussing the RF Elements sector carrier class antenna line. This is our line of traditional form factor sector antennas with some pretty unique and very high valued modifications to what you're used to and how traditional sectors work. So we'll start with a little background for those of you who aren't familiar with RF Elements. We're a Slovakian company in Slovakia in the European Union. The company was founded in 2010. We currently have over 70 employees, and the majority of those employees are in R&D and product development. Our core focus is innovation and innovative products. We really try to bring game-changing innovations to products and make products that are very unique to the market in how they work, how they feel, how they look, and just all around. We have multiple offices across the world. I operate in North America out of the Austin, Texas office. Our headquarters is in Slovakia in Europe. And we also have a logistics warehouse in Hong Kong as well. So for those of you who've never seen our carrier class antenna line, you may have seen them at Microtech Moms or WISPA shows. This is basically the antenna product we'll be talking about today. And again, some of the very unique capabilities of these antennas and unique features that aren't found today in your typical traditional style sector antenna. So sector carrier class was designed specifically for cluster deployments and for co-location capabilities. The antennas themselves have very good horizontal and vertical beam performance, which is, again, one of the key features that we'll be talking about today, and how the beam performance compares to other antennas or other similar types of antennas on the market today. The first very unique feature is the integrated back shield. A lot of you may be used to buying traditional sectors from other manufacturers and then after the fact purchasing some aftermarket shielding kits to put on those antennas and add to the price of the total antenna deployment. The RF Elements carrier class sector line has an integrated back shield. Now this back shield is actually more unique than just some metal that you put behind the antenna to give you kind of front to back isolation. It actually has these very special frequency selective surfaces. And what these surfaces do are not only tuned for the frequency of this antenna, but it's really used to help form the beam to make sure that the beam patterns overlap as similar as possible, so you get very good chain-to-chain performance, and also, again, giving you very good front-to-back isolation for co-location on the same towers. It's very difficult to take an aftermarket antenna and make a shield that works for all of them, right? The shape of that shield, the smoothness of that shield, the angle of that shield is very important. It's not the same for all antennas. And how it gets mounted to the antenna after the fact is very important as well. So by having this integrated back shield, you really get the best of both worlds. You get one that's made specifically for the antenna, that's tuned for the antenna, and that helps optimize the way the antenna operates. So here's a pretty simple animation that, again, shows the difference between an antenna with or without a back shield. Quite obviously, again, without having a back shield, you get a lot more radiation out of the back side of the antenna, and therefore you have co-location issues and possible interference issues. With our back shield, you really don't see the magnitude of co-location issues that you would with traditional sectors on the market. This right here gives you one of the best views. This is an antenna simulation of a current antenna on the market right now. So this is a 120-degree sector, And what you'll notice is that the vertical and horizontal beam performance of this antenna is quite terrible, actually. The horizontal beam performance is closer to the spec 120 degrees of that antenna, but you can still see some fairly large side lobes and a lot of back radiation on the horizontal plane only. If you look at the simulation on the right-hand side, you see how the vertical plane operates in this particular antenna. And again, you can see that it's practically an omni, not really a sector at that point. But if you look at the main beam, you'll see it irradiates at roughly 180 degrees. And then you have a lot of RF leakage out of the back of the antenna. So clearly, vertical to horizontal beam performance and back radiation is not very good on this antenna. If you go ahead and you compare those beam patterns or simulations to our carrier class 17 dB sector, you'll see that both vertical and horizontal beams are much better matched. Again, they're not perfect, but they're much better matched to the beam pattern that is spec for this antenna, which is actually 100 degrees. And you'll see much better back isolation compared to the traditional sector on top. So as I mentioned earlier, again, the back shield is one of the biggest benefits. So what you're used to using right now is an aftermarket RF armor type shielding kit to put on the back of the sector. So if you look at the center simulation, you'll see the armor kit on the sector on the left, the 120 degree 19 dB sector. And what you'll notice is that, again, the front beam has been warped and has been changed, and that's what the shield does. So it gets you closer to that 120 degree main beam that you're looking for, or that the antenna should have been operating in to begin with, but you still see very large side lobes, and you see these kind of RF vortices that show up on the corner. So these actually give you some more of the back radiation isolation that you're looking for. And again, if you compare the simulation on the left to the one in the center, you can see back radiation has been diminished some, but still exists. Now, if you compare that to the performance of our carrier class sector all the way on the right, again, there's almost no comparison to how clean our carrier class antennas operate compared to other sectors and aftermarket shielding kits. There's nothing better than an antenna that's been truly tuned and not highly manipulated as far as beam pattern goes to give you very good beam performance. So again, on the back shield part of our antenna, you see very good isolation, and you see very little change to the main beam, which is the most important part of the beam pattern that you're looking at. Also, price performance. So you can tell again that the pricing for our carrier class sectors is practically half the price of traditional sectors on the market after you add shielding kits. So from a value perspective, again, the RF Elements carrier class sector line for traditional sectors is definitely priced really well, and the quality is really high, as we'll get into later, compared to other antennas. So balanced beams, again, is yet another very important factor for antenna technology, especially today as we get into MIMO 2x2, 3x3, and even 4x4 in the future. A lot of you may have seen with your current deployments, if you're not using our carrier class sectors, you may see very poor performance in chain-to-chain performance. So you might have a CPE in the field that has a, for example, neg 60 signal in vertical, or chain 0, let's say, and something like a neg 65 or even 70 on chain 1. This mismatch in chain performance and signal intensity really affects the overall latency and connectivity quality of your CPEs. That poor CCQ number that you see sometimes can definitely be attributed to unbalanced beams, especially on the edges and in the front. Again, our carrier class sectors aren't perfect, but they're near perfect. You can see how the vertical and horizontal beam patterns are fairly similar compared to the mismatched beam patterns of other mainstream sectors. Again, another big issue that we have here is again on the edges and on the front lobes. This is also leads into kind of the mismarketing or misspecification of other mainstream sector antennas on the market. Typically, what you're getting is kind of an average or a peak of some of these specific specs. For example, you buy a 90 or 120 degree sector that's on the market right now, you're getting potentially a 100 degree vertical and 130 degree horizontal beam angle, and the average of those two come out to about 120, so they sell it as a 120 degree sector. Same thing happens with gain across the spectrum. So you have some of these really high gain sector antennas like 22, 21 dB, and usually that gain is for a specific frequency on a specific polarity. And the problem with this is that not only are you getting mismatched chains 0 and 1 as far as the beam performance goes, but you're also getting mismatched gain. So you might get a lower gain in the horizontal versus the vertical chain. And again, all these mismatches and all these poorly balanced antenna radiation patterns are directly proportional and related to poor CCQ numbers, poor connection quality, packet retransmissions, and latency rates. So again, a balanced sector is your best sector, even if the gain of that sector is slightly lower than other ones on the market. So it's something to really pay attention to. Again, as we talk about the balanced vertical and horizontal beams, here's yet another antenna that's on the market. This is a more highly focused 45 degree sector antenna, spec'd at 22 dB. Clearly on the left, if you look at the horizontal and vertical polarizations, you can see that the beam pattern in vertical is much wider and the horizontal is much narrower. Again, you're getting this kind of average of the two beams and specking it at some 45 degree. As well as the gain, the horizontal is much more focused, so it probably has a much higher gain in the horizontal polarization versus the vertical. So you kind of pick the highest gain number from the best beam pattern, and then you take the average of the two beams to spec what the overall beam performance is. So it's a very poor way of speccing and selling antennas. On the right-hand side, you can see our 20 dB 5 gigahertz carrier class antenna. Again, you can see the beams are very similar in both vertical and horizontal polarization. Again, they're not perfect, but you can clearly see that they're much better matched and a much truer spec antenna as to other competing antennas on the market. If we look at our two 5 gigahertz sectors, again, we offer a 17 and a 20 dB sector. When we overlay the maps, you can again see how the horizontal and vertical beam patterns are extremely similar and almost perfectly matched, right? So again, this type of balanced beam patterns is what gives you very good performance. And again, even in a lower spec gain antenna, having matched beam patterns really gives you much better performance. Sometimes it's more important than an extra 2 or 3 dB of, again, extra gain on the antenna. So along with the balanced beams, we actually have optimized beam widths. And what this means is basically when we created this antenna, we decided at the time to not make a 90, a 120, a 65, and a 45, kind of these standard geometries that a lot of other antenna manufacturers are pushing out, that are doing it from kind of a marketing space, right? They think that, you know, they give you more options and you can put more of these up, and really when you look at how these antennas perform from the simulations, you can see you're not really getting what you think you're paying for. So when you look at a traditional sector antenna, it's built off kind of the same technology. There's a patch array that's inside this antenna housing that creates your sector, right? And this patch array kind of has a natural beam angle that it wants to irradiate at, right? And that natural beam angle for that antenna is roughly 75 to 80 degrees in the -3 beam width measurement, and roughly about 100 degrees in the -6. So what we decided to do is to not manipulate that beam, because if we were to adjust our back shield and those frequency selective surfaces and adjust those to squash that beam down to a 90, or force it to a 90, or force it to an unnatural 65 or 45, we would create huge side lobes, right? So by leaving that natural beam angle of that patch array as close to what it wants to be without over manipulating it to try and sell you an antenna that you think is 65 or you think is 45, we stayed with the natural beam angle. That's why all our antennas are spec'd at roughly 100 degrees at the -6 and 75 degrees at the -3 dB measurement. Our carrier class sector line also comes in two varieties. We have 2x2 and even a 3x3 model. Now the 3x3 model was made specifically for MIKROTIK. There are not many 3x3 CPEs, and quite frankly I haven't really found many mainstream 3x3. There aren't too many. But we again created it because MIKROTIK had an AP for it, and there are some slight advantages to having a 3x3 AP in sector compared operating with a 2x2 CPE. The speed advantages are not huge, not what some may say it should be because you're running triple chain. But you really would see that huge or that bigger benefit if you had a 3x3 CPE. So let's look at 3x3 and kind of explain this again as to what you would see and how would you use it and when you would use it. So again, a 3x3 sector is not really going to buy you a huge performance increase, but it will help increase or decrease, I should say, latency and packet retransmits and stuff like that. So it does optimize your network a little bit better. You might see a better improvement in your end customer's user experience. Again, pages load faster. Again, unrelated to speed directly, but more about latency and retransmits. So if we look at using a 2x2 sector on the left with 2x2 CPEs, we can make an assumption that over time as packets transmit, some packets are lost. It's just the way wireless works. So if you look at those packets with the X's in them on chain 1 and chain 2, those are the ones that we're assuming are lost. And if they weren't received on time or when they were supposed to by the AP, then the AP will ask for a retransmit. Those packets will come back, and therefore it takes longer to deliver the final data stream. On the right-hand side, if we have a 3x3 AP, basically you end up having a third polarization or a third antenna element that's also listening the whole time. So the theory and the idea behind using a 3x3 at the AP side is that there is a chance that that third polarization is able, or hopefully does receive, that missing packet that was missed in chain 1 and chain 2, and then your radio is able to stitch that together and not require a retransmit. So using a 3x3 antenna definitely gives you some potential improvements. Again, they're not huge, but they could be. Now these antennas also come in two different varieties. So we have a double vertical with a single horizontal pole, and then we have a double horizontal with a single vertical polarization. And the reason for that is, or the question that we get most about which one to use, the answer is typically wherever you have the most noise or the most multipath, that is the polarization you want to use to double in. So if you have high noise in your vertical pole on a specific segment of your tower, then you want to use the double vertical, single horizontal 3x3 antenna. If your noise is in the horizontal polarization, then you want to use the double horizontal, single vertical. And the construction of these antennas, the unmatched pair, the vertical horizontal, is your standard patch array with the vertical and horizontal lines coming into the single element. But that third polarization is actually spatially diverse, right? It's its own element, either vertical or horizontal by itself. So it's all combined in the radio. So our antennas are very robust and durable. Again, we've been building these antennas for quite some time, so we have a long history of many years of having these things deployed in the field with a large amount of user data coming back for both the lifespan of these antennas for oxidation and other stuff and deterioration by being out in the elements. So again, all our products are built with very high quality UV resistant ABS plastic. We use high quality extruded aluminum, stamped aluminum, and stainless steel hardware. So again, the quality build of this antenna is very good. Even though its price is very economical, you're not getting some cheap, Chinese manufactured, low quality materials being produced here. It's very, very high quality, very good performing antennas. So we did our own little scorecard. Again, you can kind of look at the matrix that we set up, and we compared our 20 dB 5 gigahertz sector to, again, some other mainstream sectors that are on the market, including a titanium sector and some Air Max sector. So if you compare the gain comparison, you can see that again, our 20 dB sector is pretty much scores the same as the 20 dB Air Max sector or the titanium 20 dB sector as well. So from that standpoint, on gain, they all are pretty much even. If we look at VSWR performance between those antennas, we score higher. We have better VSWR on our 20 dB 5 gig sector compared to other ones on the market. The 19 and 20 dB Air Max and titanium sector still have very good VSWR performance, but not quite as good as our carrier class sector. The other item to look at again is the high quality materials. The only thing that comes close is the titanium sector. It is a very well-built metal sector, but we have seen, and a lot of users have seen, that the galvanizing films that they put on the antenna, or the steel, or some of the steel and some of the mounting brackets and stuff, still do oxidize screws and stuff like that. So the overall material list for quality is not as high as our carrier class sector. So again, our carrier class sectors will look just as good after a couple of years than any of these other ones on the market. If we look at weight, again, it's an extremely light sector compared to other smaller sectors, and this is without taking into account shielding kits that are put on some of these of these mainstream sectors. So really, you buy one sector, it's one weight, and that's it. There's nothing to strap to it and nothing to try and improve it. As far as price goes, again, it's equally priced with a Air Max 120 or 90 degree sector. So from the overall value, if gain, VSWR, quality materials, weight, and price is important to you, we score the highest across all those different scoring ranges. So a frequently asked question we get is, is that a CAMBIUM sector? If any of you have used CAMBIUM radios, you'll see that CAMBIUM's sectors have these kind of back shield built into it. And I can tell you that there's no comparison between the two as far as performance. They only look similar, but they operate nothing like each other. So we put this little, comparison chart together to kind of show the differences between the two. So again, we only have a 100 degree sector. So if we're looking at our 20 dB sector, you can see that our gain is pretty much 19.7 dB. And CAMBIUM's 90 or 120 degree sector is roughly 15 to 14 dB. So again, the gain specs are not similar at all. Again, VSWR, we're at 1.35 to 1 compared to the CAMBIUM 1.6 and 1.7 to 1. The front to back ratio, again, CAMBIUM scores pretty high on their 90 and 120 degree sector at 32, where ours is just above 29. Port to port isolation, cross polarization, size and weight, you can see again there's no comparison to any of those different dimensions. So the antenna is very different in its construction and its performance compared to the CAMBIUM. So they are not the same antenna, even though they look pretty similar. as I mentioned earlier, we have 2x2 and also 3x3 antennas. In the 5 gig 2x2 class, we have two antennas, the 17 and the 20 dB. There are some differences other than gain. So if you look at the frequency range, the 17 dB lower gain version is actually spec'd from 5240 to 5850, whereas the 20 dB version is spec'd at 5450 to 5850. So this is pretty important to know the differences, because we have had some people purchase the 20 dB again expecting it to be the complete uniband, and it's not. It's 5.4 up to 5.8 basically. Also, again, gain, forward gain of an antenna is not the most important thing. I can tell you that this little 5 gigahertz 17 dB sector is quite a powerhouse because of, again, the way it performs. If you think you need just 1 or 2 more dB to make your link, you're far off. Really, the 17 dB sector performs extremely well, even though it's spec'd low compared to other antennas on the market. So really, I would suggest that you give either of these two a try. But really, this if you need a complete band, don't be turned away by that low gain number. I think RF Elements is proving every day that gain is just a number. Really, there's no comparison to our antennas and the gain that we spec compared to other antennas on the market. They totally outperform. So the way of thinking of gain as your total link budget is really not the same when you're looking at our antennas versus other mainstream sectors on the market. We had shown the antenna gain earlier. We spoke about kind of the balance gain across the spectrum as well. So in this chart, if you look at the two black lines in vertical and horizontal, and then compare the two red lines, you can see that the gain of the red line, which is our 17 dB sector, is pretty flat, and it's pretty well matched across the spectrum. So what this tells you, or what this gives you, again, is this balance gain for when you're changing channels. So everybody, I think, has been through the situation where you deploy a tower, you have your customers connected, and everything seems fine. Later, some noise gets introduced, a new tower goes up, and you're forced to change a channel. And then when you change channels, all of a sudden, gain drops, right? Or the signal drops on some of your CPEs, but not all of them. And this mainly happens because the beam angle changes, but also the intensity of gain on some of these higher gain antennas are spec'd, again, at a peak gain at a specific polarity at a specific frequency. With our antennas, it's fairly flat. So as you change channels within the spectrum, you know that you're going to get plus or minus maybe 1 dB in gain performance change from a lower frequency to a higher frequency or vice versa. So the probability of your CPE continuing to get the same good signal and service is dependent on this type of balance in gain performance. We often hear people say, well, he's getting better performance in 5.7 than 5.2 because he changed channels, so it's not a good apples-to-apples comparison. The reason that so many people are they're not used to seeing, antennas perform the same across the spectrum is because of the way antennas are spec'd from mainstream manufacturers, and that's because the gain changes across the frequency spectrum, and you really should be seeing the same performance whether you're in 5.2 than 5.7 or 5.8. And our antennas, again, deliver that if you're in the operating frequency range for our antennas. In our 3x3 models, we have, again, two versions, as I mentioned earlier. They're both spec'd at 16 dB, but you can see, again, we have a double horizontal, single vertical, and we also have a double vertical, single horizontal. The beam widths for -3 and -6 dB measurements, again, are roughly 75 degrees on all of them in the -3, and roughly 100 degrees in -6. And again, this was done specifically and intentionally on purpose to be able to give you a balanced beam performance and a balanced RF performance of both chains. By not overly manipulating the natural beam angles of these types of antennas, you get much better performance. So again, a better balanced and matched antenna array will give you much better overall performance than some higher gain or some greater SNR based on talking louder than noise, rather than better isolation and better chain-to-chain performance like our sectors deliver. Again, here's just the plot comparisons for, again, the double vertical and single horizontal. Again, this might be a little difficult to see because it's a little bit small. If you look at our spec sheets, you probably see them a little bit better. But if you go from, again, across the spectrum from 5.4 to 6 gigahertz, you'll see that the gain performance is pretty similar at, between 16 and 17 dB. So it's roughly plus or minus half to 1 dB compared to a plus or minus 3 or 4 dB that you'll see with some other mainstream sectors on the market. Again, the double horizontal, single vertical, same thing. You see very good chain-to-chain performance or polarization performance in gain across the spectrum on both those antennas themselves. We have only one version of this antenna in 2.4 gigahertz, and this is our carrier class 214. So again, it's a kind of what's considered a really low gain or a much lower gain sector as far as the spec number of 14 dB goes and what most people are used to. But this antenna still gives you the same type of really good back isolation and very good beam performance and gain performance. So again, really having a balanced antenna gives you much better better performance than a unmatched, unbalanced antenna with a higher forward gain. If we look at, again, the -3 and -6 numbers, you're looking at pretty similar to a 75° at -3 and roughly 100 at -6. So you'll still get a very good balanced performance out of this sector as you have seen and will get in the 5 gig, and priced very well at about $130 on the market. Here again is the gain performance chart. So you see across the spectrum, it's pretty much plus or minus 1 dB max across the entire spectrum. So again, as you change channels, if you have to, you can be pretty assured that you're going to get the same signal intensity at your clients no matter what channel you're on, and therefore you don't have to worry about manipulating or being able to have customers drop off or have bad service because you change the channel. So now I want to go into the compatibility of these antennas. So these antennas are compatible with a few different form factors and a few different manufacturers out there. For MIKROTIK, we actually offer our own Station Box S carrier class enclosure. This is an all die-cast aluminum metal enclosure that's made to fit basically the small form factor radio boards from MIKROTIK, like 411s, 711s, 911. So if you're using any of those kind of small form factor router boards, they will fit inside here, as well as the ability to even use something like a 921 or a 922 with a fiber interface, right? So this carrier class S enclosure, again, will accommodate all those boards, including even a 411 with mini PCI radio modules. So you can pretty much put any one of those boards in there and build your access point with this for this antenna, as well as the rock shields that we make. So the rock shields are pretty popular for the Rocket 5M and the Rocket M2 series of Ubiquiti radios. If you're using this, our rock shield shielding kit for the radio, it will still fit and snap into the back of the sector like any other radio would. So you still have that compatibility and you don't have any issues. As far as Ubiquiti radios go, again, any of the Rocket AC lights, Rocket M's, or even titanium rockets all still slide and click in the back like you're used to, so you don't have to worry about tie wrapping the radio to the tower and then using some different pigtails or something like that. So again, any of these Ubiquiti radios or our Carrier Class S box or rock shields are still fully compatible with our antennas, as well as MIKROTIK base box, net box, and net metals. So these three radios from MIKROTIK actually require this small little plastic easy bracket 912, as it's called, and it's just a little plastic add-on that you screw to the mounting portion of these radios, and then they allow you to, again, snap in place, click in place, connect to the sector. And also the pigtail cover is also included with all our sectors, so you're still able to slide the pigtail cover over and protect not only the radio but the pigtails from the elements as well. Lastly, we have the CAMBIUM ePMP 1000 radio. Again, this one is fully compatible. It requires another plastic bracket called the Easy Bracket for ePMP. And this bracket is quite simple. You just slide it on the back, screw it in place, and then you're able to screw it or snap it again in place. Now, we've been getting lots of questions about the new ePMP 2000 radio. So the ePMP 2000 radio, as it is right now, does not work with these carrier class sectors. There is no brackets to give you that kind of clicking interface that you need onto the back of the sectors at this time. So if you have ePMP 2000s and you're thinking about using our carrier class sectors, again, it won't slide in the back, and you'll have to use some sort of pigtail interface to get the radio output connectors to the antenna input pigtails. So I just want to talk real quick about a customer use case that we have, a company called Bluespan Wireless in Arizona. They found our sectors at the Wispapalooza, as many customers have, and they really were looking for a new way of deploying their towers. They were kind of tired of the overweight, overcost of shielding kits for other sectors, and they were also not really seeing kind of the AP loading or the performance that they'd like to see across their APs with their existing mainstream sectors. So they decided to give ours a try on a brand new tower. So again, their initial test site was in Arizona, and this is just some of the data points plotted for some of the customers that are out there. If you look at the rings, each ring that you see there is 1 mile from the tower. And one of their biggest concerns, and one of the reasons that they were hesitant, is, again, they were kind of, through years of marketing from other mainstream vendors, they assumed that 17 dB was not going to do it from a sector, because they were using 20 or 21 dB sectors and still getting poor performance. So they initially wanted to use our 20 dB, and we told them to go ahead and try the 17 dB sector, and they were running them with MIKROTIK net metals. So again, what they were looking for was better RF performance, an improvement in ease of installation, and a shorter deployment time, and still be able to reach the customers which they felt they may not have been able to, based on, again, what the industry considers a low spec for forward gain on an antenna. So the results were quite fascinating and quite a large improvement for them. So they were seeing better signal quality and CCQ numbers overall on all their CPEs compared to other sites. So when they compared, again, what they would see as an average signal in CCQ at a specific distance from their other tower sectors, when they compared that to the signal quality and the CCQ numbers that they were getting and signal intensities that they were getting on these carrier class sectors, they can see, quite frankly, that it was a big improvement. They were also having significantly reduced dead zones compared to the ubiquity sectors they were using before. So, there's always a huge worry about the edge of sector performance. And what I mentioned earlier, how when you get to the edge, the outside parts of the sector, how you start getting chain mismatch errors. And also because your horizontal and verticals aren't perfectly 90 or 120 as you would think, you also get these dead zones in between sectors. I mean, you think you're putting up 3 90-degree sectors and you have the angles or the azimuths just perfectly on. It's a lot easier to have a dead zone or no coverage or a single polarity of coverage in these kind of in-between angles between sectors, where with carrier class sectors, because they're 100-degree sectors, you actually get just about 5 degrees of overlap. So you really ensure that you're not getting these dead zones in between these coverage areas of sectors. So they had no worries about edge of sector performance, and their dead zones were significantly reduced, as well as, again, faster installation and a killer cost performance. The other thing that they were looking for, because they didn't have to put aftermarket shielding kits. They can get away with much lighter tower construction because they didn't have to worry about the larger wind loads and weight loads that they had worried about in the past. So the results from there is that they have moved to using our carrier class sectors everywhere. So this is, again, this is a fairly old slide. This is probably 6 or 7 months ago. This new hillside tower or tower site was put up. And again, they sent us a picture of them putting up more carrier class sectors. So not only are they building all new sites now, based on carrier class sectors, they're also going through their problematic sites and taking down their old mainstream sectors and putting carrier class sectors in this place. So pretty fascinating. Here's a customer. I don't know if many of you know AU Wireless. I believe they're in Colorado. Again, they were using our EPMP 1000 radios. They replaced, I believe, Ubiquiti sectors that they were using with our carrier class sectors, and they instantly saw signals improve from -75 to -55. So they're seeing roughly between 5 and 10 dB of signal improvement compared to the other antennas they were using, and speeds increased about 25 meg. And on an EPMP radio, 25 meg is quite impressive for an increase. Here's again another user feedback from a customer in Albania that were using our sectors, and you can see very closely co-located together on a beachfront. So not only was he looking for very good signal performance, right, in frequency crowded areas, but he was also looking for a salty environment, having a good user experience there as far as the sectors not oxidizing so much. So definitely performing for him very well in that environment as well. Again, some more feedback. We have a ton of feedback you can see on our Facebook page, on forums, in real life at trade shows. You can talk to other users. Again, we're getting really good performance. Another customer is using a Force 110 as a CPE 5 miles away and getting over 60 meg, so on a 20 meg channel. So they're quite satisfied with the performance of these sectors, and hopefully you'll see for yourself. If you go to our forum, rfelab.com, again, a lot of good feedback from actual users, not just the manufacturer telling you how good their antennas are. I know it's sometimes hard to believe, and you don't want to believe what the manufacturer says. So we just say, see for yourself, try it out. We know that you're going to be quite pleased with the performance, and you will see the performance differences that we state in our spec sheets and everything. So with that, we come to our Q&A. If we have any questions, if you haven't asked them or typed them in, please do so now, and I'll open it up to you now.
Thank you, Tassos, very much. What a wonderful presentation. And it looks like we do have some questions, so I'm going to read them off to you one at a time.
Okay.
I'm going to start off by asking you if you have any marketing material for comparison on the UBTN sectors and your sectors so that we can show them to our customers.
Yeah, so which sector specifically? I'm sorry, the UV what?
UBNT.
Oh yeah, Ubiquiti sector. Sure. So we definitely have some comparisons. Obviously, you can see the simulation comparisons, right, which show the true beam performance. But we do have some other performance parameters that, again, offline, you can get with your salesperson at Microcom and send those requests to me, and we can try and get you the materials that you want. Absolutely.
Okay, great. Will you guys be at the WISPA Palooza show? And if so, do you know your booth number? Because we're going to be there.
Yeah, absolutely, in full force. We're going big this year at WISPA Palooza. So we'll be at booth 706, so 706. And we're looking forward to meeting all of you and everybody. So yeah, please come out, introduce yourself, and we'd love to hear from you. And again, RF Elements as a whole is we're trying to really break the mold for manufacturers. We're trying to be as transparent. I believe we are being more transparent and more honest with our specs than a lot of other manufacturers out there. And we are also transparent about the pitfalls and potential issues, right? So we want to hear not only just the good feedback, we really want to hear if you have any negative feedback to see how we can improve the product. So yes, please stop by the booth, please talk to us, and we look forward to meeting all of you if possible.
Thank you, Tassos. Yes, our sales manager, Jonathan Crilly, will be there. I don't know, I can't remember our booth number off the top of my head, but I'll let him know that you're at booth number 706. So I'll make sure you guys can connect.
Definitely.
At the show. Meanwhile, I do have a couple more questions for you.
Sure, I have time. Go for it.
Yeah, does your website have a Q&A section that we can find?
So our forum does. If you go to rfelab.com, so we have a lot of marketing and media stuff out there, right? So let me just tell you a few great places. If you go to our forum, let me just go to the next slide here real quick. So if you go to our forum, rfelab.com, there's a lot of good FAQs there. If you go to our product pages, you will see, again, a lot of high-res videos, high-res pictures of product, and a pretty detailed spec, for, again, the different specs of the products that we manufacture, as well as a lot of good marketing materials and brochures. Everything is online. Our YouTube channel is just packed of videos. Not only do we have video interviews with customers giving you their real feedback and real interaction, we also have some kind of tutorials and other things that we have done. So our YouTube channel, again, is youtube.com user RF Elements. Our Facebook page, we actually have a new Facebook user group called RF Elements English. So it's the English version. And then again, like I said, our forum is another great place, rfelab.com, to grab a lot of that information. Now, with that said, if there's something that you don't see, again, feel free to just reach out to us direct. You can go through, again, your salesperson at Microcom if you choose, but we're open. Please just email us direct and ask us for whatever you want, and we'll try and provide you with whatever pictures or animations or anything that you may need to better your website or whatever it is that you need for the product. Absolutely.
Thank you so much. I think we've got one more question.
Sure.
Who would you say is your closest competitor, and what differentiates your products from theirs?
Yeah, so that's a hard question. We have two antenna lines, right? So in our traditional sector, it's kind of hard because we've built everything into this sector. So I honestly feel that there isn't much competition, right? Now I know that's kind of a biased thing to say, I guess, but really when you look at the price performance, you look at the features that are built into the antenna, there aren't any other antennas that are manufactured, spec'd, and perform the way our antennas do. Especially if you look at our horn antennas, which a lot of you may have already been through that webinar or have seen them before. There is no competition in the symmetrical horn space, so truly we are 100% the leader in antenna technology from that. And again, it's really hard for me to say any other mainstream antenna manufacturer out there that comes close to our antennas, because they again, even in the traditional form factor, are very unique with built-in backshield, again, balanced beam performance, balanced gain performance, again, the construction quality and the material quality. I honestly feel comfortable saying that there is very little competition out there. Sorry.
Got it. Thank you, Tasso, so much, and for answering those questions and for your honesty on that last one. So that's fantastic.
Yeah, I mean, if you want to look at the mainstream manufacturers out there, I mean, Ubiquiti is one of them. KP Performance is another one. MTI is another one. They all make sectors in this space. But again, if you look at all those antennas and the way they're manufactured and the features that they have built into them, none of them have all the features that we have, right? So it's really hard to say that there's an equal comparison on the market. I truly believe we're innovative and we're unique in every aspect.
Thank you very much. That thoroughly and clearly answers that last question. And like you mentioned, if anyone has any further questions or wants to view the products mentioned or shown here today, please visit us at www.microcom.us or contact your sales rep as well. And remember, this webinar presentation was also recorded and will be uploaded to our Microcom YouTube channel. So to reference it again, you can view it on YouTube. Thank you again, everybody, and have a great day. And Tassos, thank you so much for your terrific presentation today and answering all those questions.
Yeah, thank you.
Have a great day, everybody.
Thank you. Bye.
Thank you. Bye-bye.